Hello and welcome to this short video on what is new in Eclipse Freebird Tools version 4.0. So what has changed in 4.0? So we have three improvements that make Bird easier to explain, debug and scale. So we have clearer lineage, we have a row lineage which shows how outputs were formed row by row in executable Bird transformation rules. We have flexible sources where you can now use the Bird logical data model as an alternative source to the Bird input layer, and we have AI ready workflows. So this gives us better insights, more choice and faster delivery. We would recommend viewing this video on the Bird Software Solutions YouTube channel. This was displayed or shown in the workstream prototyping back in February 2026, and that shows you how to get Eclipse Freebird tools working in 20 minutes with no need to install anything on your own machine. So it's nice and easy, and there's a link here. So for our first new feature, row lineage, we've always had row lineage available, but now the visualization is better and clearer, and this allows us to trace output rows back to inputs, show transformations in context, debug issues with transformation rules faster, and support complex corep style transformations. So let's jump into a demo of that. So we know from before, if we want to run Eclipse Freebird tools, we just go to the free GitHub site for EFBT, that's here, and the master branch, and we do add code space. And this will do a setup, nothing's on your own machine, and we've shown in the previous video how to do this, so we'll skip that step here. Okay, so our setup is run. We'll jump straight to our template screen. Our setup is put some small test data into the system also. So let's execute the all the calculation rules on the top of the test data. Okay, it's pretty much instantaneous. And then we'll take term loans, one of our cells here, view the lineage. And we'll show here our lineage features step by step. So first I'm going to drag and drop so this is easier to view. Okay, I've rearranged the tables a little bit here. So at the top we have the data point. This is for our other loans cell, row 60, column 5. Here we've enabled table lineage, and we'll look at these different lineage types in order. And table lineage shows us that we created a join, or we linked together tables for other loans, and we point to the tables we linked together. And the same for non-negotiable bonds, we linked together a different set of tables, so we joined them up or linked them up. Then we're going to show row lineage. So this links from row to row. An interesting thing here would be to show, let's do this. So let's see our instruments. We end up with this row, this fed into this row, this fed into this row. So we have the row lineage. Now this is fairly useful at the moment, but when we come to do complex calcs like corep, we'll have things like netting, where one row needs to link to multiple rows that are netted together, or one row might have been fed from one collateral row into exposure rows for credit risk mitigation. So this becomes very important for complex calculations. Then we have the more standard column lineage. This is a bit more intuitive. So we see, for example, in this sort of joined up or linked up information, we can see that, for example, gross carrying amount came from, no, let's say held for sale indicator came from here. Gross carrying amount came from here. So we see actually where the information came from. Now if we have row and column lineage, it figures that we can have cell lineage. So let's turn that on. This is my favorite feature. We can do, say, gross carrying amount. We click on here and it shows us where that cell fed, what other cells used that cell, and what cells it used. So it's very similar to the idea of formula in Excel, where you click on a cell and you know that it used this value and this value. This is the kind of thing that regulatory analysts do in their head all the time, and it's a real pain in the neck without a tool like this. It's shown as held for sale indicator, comes from here for example. Then a lineage that's often overlooked is table to column lineage. So when we join these things together to make a linked up information for other loans, we weren't just using things like carrying amount. Our joined condition considered foreign keys and primary keys, and we'll see here it points for this table, for this joined up table, to all the things that were needed. So the foreign key in the entity role table, the primary key on the instrument table, and anything else that was needed. This is very important for if you want to use your lineage to inform things like ETL and the creation of test data. You need to know all the lineage. Now you can of course show all the lineage lines. Best not to, a bit messy, yeah? So better to choose one by one. So this is our row lineage in particular, and our advanced lineage processing. Let's go back to our slide. Now something we'd like to highlight here on the next slide is that we built EFBT from the start, from the very start. We've had two design decisions to have deep row lineage, excellent lineage, and parallel in-memory processing. You can see these described in demos from 6 years ago made to the ECB that are on YouTube also. Now, what is common when designing a regulatory engine is to focus on simple things like join, filter, aggregate, the common, well understood things that you get lineage for free with SQL. But they're easy and they're good for things like FinRep. Often systems are designed with that in mind, and then the CoRep, more complex lineage, is sellotaped onto the top, and this can lead to lineage compromises and performance compromises. But because we've considered these as a core design feature from the very, very start of the project, it means that we have a consistent use of one technology for lineage and processing, and that means we don't need something separate for simple FinRep and complex CoRep. That makes things more scalable, gives us high performance and reliable lineage. So the next feature we've added is, we saw there the input layer feeding into the calculations, but we can also have an alternative layer feeding in as the logical data model for people who are more comfortable using the logical data model. So let's have a look at that in action. If we go back to the Freebird application, this time instead of using the EIL, we're going to use the LDM. We're going to load from a different source that has LDM metadata, Freebird 66, and we use a different test suite which has LDM test data. And then we're going to run all the processes we ran before to retrieve artifacts, etc., set up the database, and do this being workflow. So I'll pause the video while I do all of that, so it takes a few minutes. Okay, so that setup is ran and some test data has been loaded into our LDM structures. We'll jump to our FO5 page. Let's do execute all. Again, takes a minute. Sorry, it takes an instant, basically a few milliseconds. Let's then look at the other term loans. And we'll see the same, exactly the same approach as we had in for the input layer. Yeah, and the same kind of lineage. Let's have a look at cell lineage again. Where does gross carrying amount come from? It's over here. Oops. Let me okay, I've rearranged things a bit nicer. So here's the carrying amount here. Helper cell indicator here. And these are tables or entities from the logical data model. So a nice option there for people who are more familiar with that model. So let's go back to our slides. The last thing we've done is we've started to use EFBT with our own AI software factory within Bird Software Solutions. EFBT in total is being created with the idea to allow hundreds of business analysts to use tool support to create bird content and to make it executable and to test it. And the idea of hundreds of AI agents instead of hundreds of business analysts doing this in a collaborative fashion is not very far apart from how things work with humans driving the tools and AI driving the tools. And what we find is this helps us with two key bird cycles. One is the requirements to metadata cycle, so going from a new extension or framework into bird metadata, as Eclipse metadata, and also to go from metadata to the executable process, Python in our case, but it could be others. And this enables something truly great, because instead of taking like 6 months to work on metadata and then 6 months to make it executable and then 6 months on testing, you can do an incremental approach. So you can do a small piece of work to add or amend the metadata, make it executable almost immediately, test, and importantly regression test it. So this iterative cycle is a lot better, in my opinion, than the waterfall approach that we have currently, and AI can assist us with that, speeding things up dramatically. So this is the 4.0 message. We believe it makes Bird and its tooling cleaner, more flexible, and automation ready with faster AI assisted workflows. I hope you find that interesting. Thank you for watching.